Thanks for joining in. We are going to start the session today to learn Java. Basically, this program I comprised into two parts, like 30 minutes each, because the Zoom meeting is only available for 30 minutes. And then we can disconnect and then you can join back. And basically, we are going to start with the concepts, how we have designed the structure. Hope you guys have already seen the syllabus. If you guys don't have a chance, just go through it and see where we are going with. And so every day we'll be having the class like based on the schedule, like Tuesday, Wednesday, Thursday. Also, we are having like question session, like where we'll be talking about like any questions if you guys have to understand the concept again or go through it again. We can exchange our knowledge over the WhatsApp group as well. If you guys have any questions. So before we start today, anyone have any questions or any expectations or any questions? Please go ahead. So, okay, perfect. Okay, so this is the first class we are going to start today, where we are going to talk about Java very beginning. I know some people already worked on Java and some people are like very new to the Java course. And this is actually covering end to end to start from scratch and to get in detail about Java. So the way how I'm learned Java is based on the experience and do a practical coding, and moreover the love towards Java that makes me to be an expert in Java. So if you guys want to learn in and out of Java, better you can start, write the program, whatever you understood, and try to see how it works. And if you have any question, like you can ask me at any time. And if it's still you are not clear, like you can Google it saying, what, why, how. So you will get in and out of it. So this is the course content. As you guys know that like we're going to start with core Java basic concepts, OOPS concepts, and fundamentals. And also we're going to start with, control flow statements. And most of the people are having struggle in learning collection framework and multi-threading. And I have seen many developers really struggled in getting into collection framework and multi-threading. So especially I have made more videos or multiple, concepts, split it into multiple concepts to get in and out of it. Not only theory, everything is going through with coding. So you guys don't need to worry about collection and multi-threading. And finally, we are going to start with Java 1.8 features. So once we go through in and out of each section, you will see why we are learning this particular section and what is the importance of each section before we get into the next one. So let me start with the first thing. So today, this is the agenda for our class. So we are going to start from how we can start learning Java from the scratch, and what is Java, what is JDK, JRE, JVM, and what do you mean by platform, and we will understand like how one Java is platform independent. So this is very looks very simple, but if you go for any interview, sometimes even the experienced people like they might ask the same question to understand how we understood the core, the framework, right? The core language. So it is very important to start from there. So the way how to start learning Java from the scratch is, understanding the answers, whatever the concepts we are learning, understanding the answers for what, why, and how. So in the IT industry, for anything we learn, in my aspect, if you know what is that and why it is like that, and how it works, or what will be the importance, or why, or what will happen if that doesn't exist, right? So if you go through all these answers, like you will get in and out of all the concepts, like knowledge, more knowledge, and also doing the real-time coding by practice. That's the only way. So since Java is an open source where it is free to use, we can easily learn by doing practice. Multiple platforms are there to do a practice. We can go one by one. And as I said earlier, these are the topics which we are going to cover in this course. So before we start, I want to go like some decades before we start learning about Java. So when we want to communicate to computer, right? So we know like zeros and ones, and computer knows only zeros and ones, right? But how we can make computer understand what we're trying to communicate to it, so that like it can perform its task, right? So there was no language in before like 1940s before that. So in 1940, there is a person called David J. Wheeler who actually created some, assembly language. They call it as low-level language. We will see what is assembly language and how it works, but it is something like, the history behind the programming language evolved. So what he did is like he created a set of instructions to do some kind of activities. So he used like electronic delay storage computer, which he wrote a language or the program, which is nothing but a set of instructions, which they call it as assembly language or low-level language. If you guys see my screen, the initial language looks like this. So this was able to understand by the computer by converting into zeros and ones, but this was not actually machine or like human readable both, right? So that is where actually they want to come up with some new idea. So if you want to do something in assembly language, let's say you want to add some two numbers, right? So what we have to do is like, if you guys know about like microprocessors, right? So where you will store the number in memory A and then another number in the memory B, and then
Sorry, Karthik, to interrupt. Can you admit like Jayashree? She's waiting in the lobby.
oh, okay. I don't know how to admit. Oh, sorry. Hi, Jayashree. Okay. So if you want to store two numbers, let's say you are having like A and B, you want to store it in one memory and then another number in another memory, and then you want to add the contents and store the results. It looks like very simple, but it in terms to computer, if you use the assembly language, it looks like this. So in assembly language, you have to write like this, right? And that assembly language will be converted into machine code, zeros and ones, which can be understood by computer. So in order to make that into zeros and ones, they are using a product called assembler, which actually converts whatever the program you write in the assembly language into a machine code. This looks okay, but if you see how it is processed, whenever we write a program in assembly language, once the assembler converts into zeros and ones, that will be processed by a processor, right? The way how we are using processor nowadays, like Intel Core and IBM, lot of AMD's processor we have. So this can be processed by the processor. But the thing here is, this is not able to understand by everyone, right? The assembly instructions are not able to understand by everyone. It was very difficult to make everyone to understand the logic and how to work on it. So that is the story behind the high-level languages has been evolved. Excuse me. So if you guys see here, like a language example C, if you want to store the results and add the two numbers, right? In C, you can simply use printf of A plus B, right? As simple as such. So printf of A plus B actually adds it, right? So basically you can print it and you can add it, right? You can able to see the output as well. This is basically easy to understand by the human, or even anyone can able to go through that logic. So what it actually does is, in C language, the compiler actually does the remaining part, like converts into assembly language, and again assembler converts into zeros and ones. That will be processed by the processor. So as a developer or as a programmer, we don't need to worry about how the assembler things works. So whenever I say a processor, which is nothing but the platform which you are using it, right? So let's say you have an operating system and processor. Whenever we buy a computer or laptop, right? So you will have a like OS like Windows or Mac, right? And then you have like a processor like Intel processor, and the combination of these two will be a platform. So there are some challenges which was developed in those days, like C, C++, where they're having some problem with these high-level languages. So the language, whatever they have built, is like robust in terms of functionality, but there is a problem. In those days, there are a lot of platforms has been evolved. So like Windows OS, like Mac OS and Linux, there are a lot of platforms has been evolved. So the problem with them is like, once they write the code in the C, they are not able to execute in the other platforms. And in those days, the platforms are evolving like anything, right? So that was a problem, and that is where they thought of taking a diversion of creating some other language wherein they want to avoid that disadvantages of having a multiple platforms. So that is where they come up with a language called Java. If you guys knows this already, like it was developed by James Gosling, and it was actually a high-level language. But the beauty of Java is that you can write once and you can run anywhere. So we will go through the next slides where we are going to see what does that mean. But this is like everything is class-based, object-oriented, platform-independent. So basically, Java is one of the beautiful language where you can learn easily, and how you are learning is makes the difference in the understanding the concepts. I would strongly recommend you guys to go through each and everything, so that like if you want to pursue the career in Java, which is one of the topmost hot technology in the market, and not only in that, like you can also build some products in your lab. So typically, I used to develop some of the products like using Java frameworks, and understanding the base concepts is very very important, because once we get into a project where you start developing a Java projects, you won't get a time to go back and see how that works, right? So this is the place or time to learn in and out of it. So typical way when I say write once and run anywhere, this is the pictorial representation where I'm saying Java code. If you guys see here, whenever I'm writing a Java code, I am storing it as .java, and there is a compiler. Basically, it is used to compile the code from .java into .class file. And this class file looks like this, where you won't be able to understand even that is kind of assembly language where it will be like bytecode. So there is a concept in Java which is called JVM. If I say Java is way differ from other languages, that is because of JVM. That is the heart of Java. If anyone asks you any question in interview or even in your real-time world, how you think like Java is more powerful, then you can always say that it is because of JVM. Because the JVM is the one who actually sits in your RAM and which converts into zeros and ones that will be executing the program in the platform. That is why it is called platform independent. Whenever you write a code in Java, you store it as .java file, and using the compiler, you're compiled into .class file. Whenever you execute that particular .class file, you can execute in any of the platforms. So you can write once in say .java, and you can run in any platform, which is nothing but like Windows, Mac OS, it doesn't matter. So this is one of the beautiful advantage of Java when it was evolved, because when some languages are already there, like C, C++, COBOL, Pascal, a lot of languages are already there in the market. When Java comes in 1995, at the time there are a lot of platforms are also evolving. So the people who is already there in one platform, when they're moving into another platform, they don't want to write or rewrite the code which is already written by some developers. So that is the reason like Java is mainly used by or adopted by many clients across the globe. There are multiple editions of Java. Basically Java SE, Java EE, Java ME. Basically Java SE is mainly first they created for desktop and standalone applications like calculator or any kind of standalone applications we can build. And then they moved into server client server architecture where they have used JWE. There are a lot of frameworks available in the market like Struts, Spring Boot, Hibernate. A lot of frameworks are available. And then Java ME is for mobile development. Still, there are a lot of games and mobile apps are still created using Java ME. So this is basically high-level outline of what is Java. Let me pause it here. If you guys have any question, please, we can start. Okay, no questions. Good. All right. So now we are getting into the next topic where we are going into. There is a concept called JDK, JRE, and JVM. So now you understand what is Java language, and language is nothing but like it's a medium of communication, right? Where we are trying to communicate between a computer and the human, right? What we're trying to tell the computer to do. So there is a concept called JDK, JRE, and JVM, and we are going to see one by one. So JDK is nothing but Java Development Kit. JRE is like Java Runtime Environment, and JVM is Java Virtual Machine. So let's start with JVM first, because that is a very core important part, and you will understand what is JDK and JRE in the upcoming slides. So if you see the screen, we are having like Java class. We are writing, let's say you're writing a class called main.java, and another class called m1.java and m2.java. Right? This is the file extension. You have to use it whenever you write a Java class. So let's say you're writing in the Windows machine, and that is, we call it as source code. In the programming world, we call it as source code. And then, as I said earlier, so compiler is a program which will convert that .java into .class files. Basically, Java C is one of the compiler program. I will show you guys after this complete the slides how that works. So that is a one mainly responsible to compile the code from .java into .class file. We can call it as class file or bytecode, both are same. So let's say you're writing like program in Java, let's say hello world, and using Java C, you are compiling it into hello world.class, and you have to execute that, isn't it? So how you can execute that class file is with the help of JVM. So let's say you have a laptop and you have a RAM of, let's say, 8 GB of RAM. So in that RAM, actually, JVM sits. So JVM is actually nothing but the Java virtual machine, which is the heart of Java, who is going to execute the program. So within JVM, you will have like class loaders, bytecode verifier, and then JVM engine, or you can call it as JIT compiler. That is called Java just-in-time compiler. That is a place where it is going to execute it. So it will go by one. So whatever the classes we have created, whenever you try to execute the class file, the class loader is the one who is going to load the class with .class extension into the JVM. Once it gets loaded, it is going to verify that bytecode, whether it has any error in the class or not. So once it verified, it is going to execute it by the JVM engine. So it is nothing but the Java just-in-time compiler, which is internally used within JVM. And there are like some more developer, jar files associated with JVM. So this is how the actual .java is converted into .class file that is getting executed in the JVM. Basically, JVM sits in the RAM. If anyone asks you about tell about how the JVM works, you can simply execute this way of explain in and out of how the .java is converted into .class file and how the class file is getting executed by JVM and where the JVM sits and how the machine code is converted from the bytecode, and then you can say that that machine code is executed in the processor. So during runtime, this is how actually JVM is actually using the class loader. It loads the class files and convert into a machine code. So this is actually in and out of JVM. Now we will talk about JDK or JRE. So JRE is nothing but the runtime environment within which the Java virtual machine sits. So when I say JVM sits in the RAM, in your RAM actually the JRE will be there, and within that JRE you will have a JVM, and along with that you will have some set of libraries. So basically these are set of libraries are already developed by Sun Microsystem, which was now acquired by Oracle, and this set of libraries are kind of system files which are associated to compile the class loaders and convert that into machine code by using JIT compilers, all the stuff. Basically, JRE doesn't contain any compiler or debug, debug any tools like that. These are like developer tools. So JRE is nothing but runtime environment. When I say runtime environment, it is just to execute the program during the runtime, which means, let's say you have someone is giving your class file and you want to execute the class file, then you need only JRE. You don't need JDK. I will go by telling the difference between what is JDK and JRE in the next slides. But just to make a very clear point here is JRE is just a runtime environment within which JVM sits, wherein you will have other set of libraries. It is just to execute the class file into a machine code and get into processed by the processor. JDK is kind of superset of JRE. Basically, JDK is nothing but whatever the JRE contains. Along with that, it will have developer tools. So let's say we want to learn Java and we want to develop some programs and we want to execute the programs, right? So whenever I want to develop some program, meaning I am going to create a class file as .java, and then I want to convert into .class file, and that class file I want to execute it, which means you are trying to compile your .java file into .class file with the help of Java C. That is one of the developer tools. So whenever you want to write a program, you want to compile it, you want to execute it, then you need JDK. You don't need separately JRE because JDK itself contains JRE. So as a developer, we should have a JDK, not a JRE. Let's say if the user is there and they're trying to execute some program, they just need JRE, they don't need JDK. So JDK is a superset of JRE in which they will have developer tools like compiler and debugger, and along with that they will have a JRE, which means like it is the part where it is going to execute the JVM and other set of libraries. So in summary, if you see JDK, so JDK contains JRE, and along with that you will have developer tools, and JRE is basically runtime environment where it contains JVM and other set of libraries. So JRE is actually runs under RAM. So if you guys think about like when you're buying a laptop, let's say you're buying a laptop for like 8 GB of RAM, other one is buying a laptop of 16 GB of RAM, and let's say you are having a Java code and you want to execute that one. Assume that Java code is doing some infinite, loop is there and it is keep on running forever when it runtime is throwing some error like that, right? So if you have 8 GB of RAM, basically you will see how much memory is consumed for the program versus 16 GB of RAM laptop, how much memory is consumed on that laptop. You will see the performance difference because it is because of the JRE, the JVM sits on the RAM. So that is the reason like they will say the minimum requirement for a developer to have a JDK install on their machine, they should have minimum of 4 GB of RAM, something like that. There is some configuration. So this is basically a summary of JDK, JRE, and JVM architecture. So the question you guys might have it is, okay, I want to learn Java and I want to become a Java developer. So then what should I have? So you should have a JDK. Let's say you are working in a project where you have some users and they want to use that your program to execute it, right? So what do they have? They need JRE. Assume that let's say we are users of using Chrome browser, right? So let's say that Chrome browser is developed by Google, and we are the customers or we are the users actually using the Chrome browser. And in some places, if you're having some Java applets running on your Chrome browser, you just need JRE, not JDK. That is a typical practical example where you can understand about JDK and JRE, who is the developer, who is the user, right? If someone wants to use your application or your program, they just need to run it. Just to run it, they need only JRE. They want to execute it, or if you want to develop and execute it, then you need just JDK. So I hope like you guys have understood about JDK and JRE here. And now we are getting into topic of what is platform and why Java is platform independent. So when I say platform is nothing but operating system and processor, right? Whenever we buy a laptop, it can be a Mac OS or it can be Windows laptop. So Mac OS is nothing but operating system. Windows is an operating system, and the processor is nothing but like Intel processor or IBM processor or AMD in terms of Linux, right? So the combination of this one you can call it as a platform. That is the reason in olden days they used to call your laptops are called like platforms. So what is platform independent, right? So whenever we write a code in one platform, let's say Windows machine, you can able to execute that same code on another platform without touching or without modifying the code. So we call it as Vora, like write once, run anywhere. Basically, this was very helpful when very first time when Java was evolved. At the same time, when multiple platforms are also evolving, because customers or the clients don't want to move from one platform to another platform if they want to rewrite the code. But that is where the Java makes the life easy in terms of getting huge market by adopting Java to most of the projects. And how the platform is making independent in terms of Java, that is because of JVM. So that is the reason people have to understand very clearly the JVM concept, because everyone knows how to write a Java program or how that code works, but in detail how that actually the .java is getting executed by Java language is what a developer should understand. So that is because of JVM only the Java is called platform independent. Now you will understand why I'm saying JVM is the reason for platform independent. So if you guys see here, the main.java, m1.java, m2.java, right? So these are all the class file, .java files which has been created by you in your Windows machine, which is getting compiled by the compiler by using Javac, and then which converts into .class files, which is getting loaded into JVM with the help of class loaders, and then finally getting executed. So if you guys see here, the source code, whichever you're writing, right, that is called platform independent, because once you write your program in .java, which means like you can use it to run in any platforms, That is why it is called platform independent. But if you guys see here the compiler is a platform dependent. The reason behind that is compiler is the one who is going to convert the .java into .class file accordingly to speak to the RAM, which is like JVM. So that is the reason Java C is a platform dependent, and the class files whichever you guys created with the help of compiler, that is nothing but a bytecode, that is platform independent. Whenever I say platform independent, the same .class file can be executed in any platform, which means like Windows machine or Mac OS or anything like that. So that is the reason we are calling it as JVM is the one who is actually depending on the platform. So because of JVM is platform dependent, they call Java as platform independent. I will show you guys how to verify this one. I will go to Oracle website and I want to show you guys how I can say that Java is platform independent. But for now, we have to understand that source code is what platform independent, and Java C is a platform dependent, and the classes which we are compiled into the classes, right? That classes are like platform independent, and JVM is platform dependent. So because of JVM is dependent, that is the reason Java is platform independent. In olden days, people used to ask the question, how Java is platform independent, and they used to say JVM. But we should know how JVM is making Java language as platform independent. So this is the reason where JVM is platform dependent. Because of this, Java is platform independent. Okay, so this is all about like theory about this particular class, and I want to rejoin back, and then we can start from the practical ones where we can start from how to see this in the real-time programming. Okay, so basically, you guys can see about how to install Java on Mac or Windows. That is a kind of work that you guys can do it before the next class so that you will understand. Come up with some any questions if you have while doing it. Not sure if you guys already have Java installed. So when I say someone says Java is there in your machine or not, make sure if you're a developer, you should have a JDK. If you're a user, you should have a JRE. That should be fair enough. So let me show you guys where is JDK and JRE sits. So if you go to Java, once you install Java, you'll see like this. So you will have like the JDK 1.8. So this is the version of Java I have. So let me show you guys. Yeah, if you see here, this JDK actually contains JRE, right? And which means whatever the JRE contains, this should be sufficient for a user to execute any Java program. But as a developer, if you want to write a program in Java and then you want to convert into .class file, this is not enough. The reason is that if you go to bin folder of Java JRE, you will see only the program called Java. You don't see Java C, isn't it? But when I say .java has to convert into .class file, which means you need to Java C. If I go into JDK contents in the bin folder, I can see Java C as well as Java. These are all executable files. Basically, this is what you're going to execute, or you're going to run the command, which is going to convert that into .java into .class file. This is the reason we have to make sure Java means JDK. For the user terms, it is JRE. For developer terms, it is JDK. Whenever you have JDK installed on your machine, you should be able to write a program and compile it, and you can able to test it. And if you want to create a Java documentation, you can use Java doc. There are so much of libraries are available and executable files are available in terms of Java, where you can use it to enhance the product or whatever you are developing using Java. So JRE is fair enough for executing a program, and JDK is required if you want to create a develop a Java language, or sorry, not a language. You are writing a program and you want to execute it. So this is the actual contents of JDK and JRE. Once you guys install JDK on your machine, please let me know if you guys have any questions on the contents or the concepts, so that we can discuss in the next class. but JDK and JRE, that this is the difference. And when I say, yeah, before I go into that, like any questions over here? Anyone have any questions? Okay. So if I say that if you want to install Java, oracle.com Java, basically you can create a user account, which is a free account. You guys can have it, and then whenever you go to Java download. So right now, Java 17 is available in the market, which is latest long-term support. What does long-term support means? Oracle actually supports latest long-term, which means like if any clients wants to have Java 17, which means anything happens over there, then Oracle is going to support it. If you guys see here, JDK 17 binaries are free to use in production and free to redistribute at no cost, which means like it's open source, right? Though we have JDK 17, I'm having a lot of concepts which I'm going to talk about in the upcoming classes, where I'm going to start with Java 1.8, why we are learning Java 1.8, even though you have Java 17 right now in the market. So what you can do here is, I would strongly recommend you guys can go here and then probably the archival, you can see the previous versions of Java, where you can use, I would strongly recommend probably this or this, either one, probably this one. Yeah, if you guys see here, Java SE8, which is standard edition, and you guys can download here. This makes to this is actually telling the developers that Java is platform independent, but JDK is platform dependent. The reason is that if JVM is platform independent, they don't need to create JDK for each processor, right? Platform. You guys see here, JDK for Linux, JDK for Mac, JDK for Solaris, JDK for Windows, right? So if you're using Windows machine, you can use JDK of Windows. If you're using Mac, you can use JDK for Mac. But why they have created multiple packages is because of the JVM, which is sits inside the JRE, that is actually platform dependent. That is the reason these guys created this in a separate for each platform. Anyone have any questions to understand this concept?
So why are we using 1.8 or SC8? Karthik, is it the most stable version? I've seen, most products use 8.
Yeah. Even if you see the Java requirements in the market, you must know Java 1.8, right?
Mm-hmm. Yeah.
So in my way of telling, Java 1.8 is the turning point in the Java history. The reason is that till Java 1.7, it was mainly object oriented, or even still it is object oriented. It was focusing only on objects, meaning if you want to do anything in Java, definitely you should have a class, you should have an object, you should have to put everything into the class. But Java 1.8 actually turn around to be a functional programming language. The reason behind that is, whenever a program is emerging, and if the competitors, let's say Python, right? Python was invented or created before Java was there, but almost like till 2018 or 19, Java was hot in the market, but all in a turn, Python was grooming like anything. Then Java, then the Java developers take a pause and then think why people are moving from Java to Python. There should be some reason behind it, right? So there are a couple of things. One is Python is very concise code. If you write something in Java, let's say you have to write in 5 lines of code, in Python you can write in 1 line of code. Then definitely people and developers prefer to go to Python. But Java 1.7, still you need to write the same 5 lines of code. But that is where they have reinvented back the entire architecture of Java, and then come back saying that, hey, Java also, you can use the same thing with code concise, and you can also implement functional interfaces or like functional programming. And that is where Java 8 is the first version in Java world where the functional programming features has been introduced. Now after that, Java 9, 10, 11, these are all multiple versions are having like only small minor updates, but Java 8 is the major one. So there is a tough competition, right, between the languages. So what they did is like if they're not giving more updates to the customers, they are like kind of saying that okay, this might be not going to be in the future, like mainframe or any kind of old technologies. So after that, they decided for every 6 months, the Oracle team decided for every 6 months they have to release some version, and that is the reason now it is 17. So whatever it is, let's say it can be useful to the clients or not, they have to release some version, and that is where JDK is the base where you are actually speaking, you are actually making the different way of coding style in Java starts from 8. And that is the reason if people are asking about if you know Java 8, the reason is that if you don't know Java 8, if you know previous version of Java 8, you can also implement it, or you can also implement the same functionality. But the way how you will write, let's say 5 lines of code or 10 lines of code, it is very difficult to maintain the code, right? But if you know Java 8, you can do the same thing within like 2 lines of code like that. So that is the reason like I am emphasizing to start with Java 1.8 features. It's a very beautiful concepts. You don't even imagine like how you can do it in Java 1.8. Once you start coding, that is where you will get deeper into the language, and Java 8 is always uh, on top of all the versions. I know like there are a lot of projects they're still using Java 6 or 7, but there are places where there is a workaround for it. If they still want to use the Java 8 features, because some clients don't want to go to Java 8 just because of that, like they might they don't have that much kind of confident about moving into that one or restructuring the entire product or entire the applications. So that is the reason like they still hesitate. But I will tell you guys tips kind of like where you can inform your clients saying that you can still use Java 8 features even though you are in Java 6 or 7. There are a lot of concepts they have introduced. If you want to do something with the date and time in Java 6 or 7, it is always confusing whenever you try to do date. So date is there in both in Java as well as in Oracle or SQL, right, database. It will be always confused which date I need to use it. But in Java 8, they have introduced like kind of local date, local time, local date time. There are so many classes they have introduced packages, which makes our life beautiful whenever you want to write code in Java 8. So that is the reason I'm also focusing on Java 8. And I have some other some other videos already there where I was explaining like each version starts from Java 1.0 till Java 13, I believe. What are all the features they have added and how it was evolved, and why do we need to learn Java 1.8. So we will see in the upcoming videos as well, classes. Okay. I mean, anyone have any other suggestions or like to start from where you guys want to start? I mean, this is kind of a interactive class, not like a video classes where you guys can get in and out of it. At any time, if you guys have any question, you can reach out to me. We can write programs and we can play around over there. The more programs you write, more knowledge you acquire, more chances of getting into this language. And definitely Java, as I can say, like last 15 years, I have seen this program has been evolved. This language has been evolved a lot. And definitely since Oracle bought Java from Sun Microsystems, it's been like hit in the market. Even though Python and other languages are still in the market, Java is kind of evergreen. The advantage of Java is using frameworks like Spring Boot, which is one of the topmost framework which is available in the market. My next class will be focusing on J2EE, where we're talking about frameworks, and then AWS.
Hi Karthik, I have one question.
Yeah, Raji. Yeah.
So if one of my client is using Java 6 or 7, can we able to migrate into Java 8 or above version?
Yep, definitely. So we
Okay.
can move to Java 8. There is no problem in it. The reason why clients are like hesitate to move to Java 8 is that because of the same the turning point of Java, right? So even though a lot of clients are already moved to Java 8, and still there are some people not ready to move, they are kind of like what will happen if I go to Java 8 and if something breaks, right? So
Okay.
if you know Java 8 as a developer, if we know Java 8 and if we can convince them saying that we can move to Java 8, the same application, and without making any backward compatibility issues, then definitely you can able to implement it. But end of the day, one say, see these clients, right, whoever is like trying to not to move to Java 8, once Oracle informs or announce saying they're not going to support Java prior to Java 8 anymore, then there is no other way. They have to go to Java 8. That will come soon actually. That's what most of the clients are moving on.
Okay.
Yeah. You got it, Raji?
Yeah, Karthik, thank you.
Sure. No problem. Actually, this class is kind of like both programming and theory. That is how I usually take the batches. So since this is the first day where I want to talk about just overview about programming language, history of how this got evolved, and even like JDK, JRE, JVM. So this is like very theoretical. Once we start getting into the program where you will start writing the code, and if you guys see the syllabus where I have written, let me show back again. Right, so we are covering this one for today, right, the day one, and then whichever the laptops you guys have, let's say Mac or Windows, try to install Java 1.8 on your machine, which is JDK 1.8, and then tomorrow we'll be going through how to write a program and how to execute it, or what are the ideas we have, how to execute it, and then we can go one by one. And basically, for each and every topics, I already have created the videos in my YouTube channels. At any point of time, if you guys have any questions regarding any of these topics, just click on the link. It can directly take you over there, and then you guys can refresh your knowledge. So the reason why, how I frame this one is, if anyone wants to go for appear for any Java interview, if you guys learn or if you guys refresh just this knowledge, I am more than 100% sure that you can clear that interview with the help of this program. That is how I have framed this syllabus. Basically, in multi-threading and all, people used to say that that is a very tough topic. People don't want to get into that. So I always wants to get into the tough topic and make it simple and share it to the friends. That's how I have framed this all this. So you guys will get in and out of it. So no worries. Even if you guys see, oh my god, these many topics we have to learn to get into Java, no. So everything you will learn it. Every step is a step, right? So you will get in and out of it. Nothing to worry. So I would strongly recommend you guys to go through this. If you guys just follow this process of 25 days or how many days? 55 days. Yeah. Then definitely you can be a Java developer. Even moreover, whenever we talk about each topic, if you start writing the program in the parallel, then even though you don't have a Java experience, you can still make yourself say you are like 2-3 years of experience in Java, and then just Java is not sufficient to get into job market. So I would strongly recommend you guys can go with Java with AWS or Java with any frameworks like Spring Boot. So I'm planning to have one more batch for you guys for Spring Boot. I'm already taking another class. So let me find some time for this batch to start with JDK, sorry, Spring Boot in the upcoming classes after we complete this one, and then AWS. So the top skill in the market is Java, Spring Boot, AWS. This is the combination to quickly get into the market. So this is very high level. You guys can just refresh this one to appear for an interview. Yeah, I'm done actually. So if you guys have any question, then probably you guys can post in the WhatsApp, or even you can call me directly in WhatsApp and we can talk. And please try to install JDK 1.8 on your machine. It won't even take like 10 minutes of time. And once you install in your machine, as I said earlier, just go and see where it got installed. How does it looks like? Is it same like Karthik's machine or different? If it's something different, then we will discuss tomorrow. Hey, Karthik, how it is different on my machine? Then I will be caught. Then we'll see. Right? So we'll see that. So anyone have a prior experience in Java in this batch? Let me see who are all there. I think Ashwini, I know her, Rajesh, Ravani, I know, Nitya also, I know. Okay, only 4 people, right? This batch. Okay. So I think all are like very new to Java real-time coding. Is that right?
Yes, no.
Yes, Karthik.
Okay, perfect.
Yes, Karthik.
I'm sure that you guys will become a Java developer. Nothing to worry about it. Whatever the projects you guys are working on now, you guys concentrate on this class and then help me in doing the coding, the parallel, so that you don't forget it. And typically what I do here is whatever I learn, I usually write a kind of lab where I create a set of projects and programs so that we can easily go through it before you appear for the interview. So I never ever read the concepts. I usually go through my lab before I appear for any interview in Java. So that like once I go through the program, I will understand the concept. Then that's it. That's a kind of refresh all the concepts before you appear for the interview. All right. Any other questions? We typically talk about all the questions in the last 5 minutes. Or anything you guys expecting to start, or specifically any other questions, or before we wind up today?
No, Karthik, I'm good actually.
Okay, perfect. Okay, all right, guys. Thank you very much for joining the class, and we will see you tomorrow. And until then, bye bye, guys. And we will communicate in the WhatsApp. We will join tomorrow then. Thank you.
Thanks for the wonderful first class now.
Oh, sure, no problem.
Thanks, Karthik. It was very clear actually. I can connect all these, dots.
Yeah, no, definitely you will connect all the dots in terms of programming as well, because I have been teaching a lot of people and I'm getting a lot of feedbacks about everyone knows Java, but how it works internally. So how you will become a Java architect, right? If you are a Java architect, you should know in and out of it. Once you become like more experienced, you won't get a time to learn all this. So always you have to strong in the base, right? So I'm sure you guys will get in and out of it. Probably I can share the keynotes what I have. Probably you guys can take a look or refresh your knowledge whenever you want, so that you guys can easily go through the concepts in the future. All right then. Thank you very much for everyone to join, and we will see in the next class tomorrow. Thank you guys. Bye bye. Have a good day.
Thank you, Karthik.
Thank
Thanks,
you.
Karthik.
Thank you.
Bye everyone. Bye.